hey, mashallah. So I have my compound now.
Crude.
The crude. I did the reaction. I don't know if I have it though, so I want to check it with the NMR. So how do I confirm that I do need to have it?
Okay, I understand your point. Like sometimes you can check the proton NMR, sometimes you can check the carbon NMR. Okay, for now, like for this reaction, which you already do, like suppose you had whatever the group, but you had some, like, is it like close by?
Yeah, not the carbon.
Or here or there?
Yeah.
So this carbonyl group or whatever, it has some other group. Okay.
Yeah.
So basically you did reduction here, right?
Yeah.
So you add lithium aluminum tetrahydride in THF. So we are not concerned about the changing other parts. So whole molecule will be there like the same, but you will know whether this reaction happened or not, like you have the product or not. So first of all, every time you do any reaction for the, like with the crude, always there will be some signature peak in proton or carbon.
Yeah.
So look on the structure and find the signature peak. So in that case, if it goes like good, like reduction happen, so definitely you will get two new CH2 peak in the proton. Okay, so originally I'm not showing your full structure, but I know originally in aliphatic region you don't have like too much of crowded peak. Okay, like in aliphatic region there is no proton, except around there should be a singlet peak around 5.2 or something. But if this carbonyl group get reduced, so that CH2 will be like, you will get around 0 to 2 maximum, this area. So those whatever the like 0 to 2 ppm, you'll get some maybe like it should show like 2 triplet. You will see 2 triplet, because this proton will see this 2 proton 2 plus 1 triplet, and this proton will show this as a 2 like 2 triplet. But I know next to it, this carbon, there will be an electronegative atom. So due to electronegative atom, you might see this proton a little bit downfield, okay, like above 2 or something. But in some cases, like if those 2 protons are not like as a signature peak, or like you never know, so in that case you can also check the carbon NMR. And in your carbon NMR, you definitely should know the carbon NMR of this starting material, where are those 2 carbonyl there. And in your crude, if you see those carbonyl are missing, that means like the carbonyl get reduced. But there is another question, like I can tell you. So if you did this reaction and you know that some starting material left, okay, some starting material left there. So in that case, in carbon NMR, you will see those 2 peak too, right? Then you can say like, oh, these 2 peaks are there. But still, if you know the pure starting material, so along with these two, and you can count how many aromatic carbon is there. And in new crude, you will see, other than this pure aromatic carbon, like suppose you have a 6 aromatic carbon. So other than that 6, if you see like more of the carbon, so that will be your product, definitely. But still you are not sure. But in that case, you have to rely on the proton NMR. So and also like TLC and LCMS. But normally from the proton NMR, maximum time we can see the proton NMR like a signature peak arise or signature peak removed. Like a peak which sometimes it can be also a signature peak. Suppose if you have a benzyl protection group, like in your molecule, benzyl protected. Suppose this part is your important part, but you have a benzyl protected. So that CH2 peak, that peak especially is the signature peak. So it can be moved or here and there, like you can integrate it, because it will be totally shown up like from the aromatic or like from the aliphatic, a certain region around like 5.2 or like 5. So that could be a signature peak. So that will help you to realize. But here I would say, if you get the, like if you starting material gone completely to the reaction, then you will see the missing of the carbonyl and the carbon.
Yeah.
But if still you have some, still you will see little small, but mostly the bigger one, the product. But in that case, in aliphatic region for your compound, aliphatic region, it will arise two triplets. So one triplet around 2 or around something, another triplet around like 0 to 2. So if you see those 2 triplet is arising, that means your product should be there.
Cool. Thanks. Sounds good.
Any more question?
No, just make sure to subscribe.